Hello, everybody. This is Anshu Singh, and today I'll be taking a session on linear differential equation. We will start in another 5 minutes. We will start in another 1 minute time.
Hello everybody. In today's lesson we are going to learn about linear differential equations. So a differential equation of the form of dy by dx plus py is equal to q or of the form of dx by dy plus px is equal to q are known as differential equations of the linear form, where p and q are constants or functions of x in the case of the first differential equation, or functions of y in the case of the second form of differential equation. So let's write down a few examples of the linear differential equations. So dy by dx plus y is equal to sin x. So if we have a look at the form which we had written earlier, in which we were differentiating the y variable with respect to x, we will see that in this case p is equal to 1 and q is equal to sin x. Whereas if we have a differential equation of the form dx by dy minus 2x by y is equal to y square e to the power minus y, for this particular form of linear differential equation, p here is minus 2 by y and q is y square e to the power minus 5. So the most important aspect of solving a differential equation is first identifying whether the given differential equation is a linear differential equation or not, when we have questions related to linear differential equation. So if our differential equation is of the form of either of these two differential equations, then the given differential equation to us is a linear differential equation. So in order to solve these type of differential equations, what we basically require is an integrating factor. So let us have a look at one of the forms which we have discussed earlier, that is dy by dx plus py is equal to q. So now we multiply this given differential equation by a quantity which is e to the power of integral p dx. So what we get, e to the power of integral p dx into dy by dx plus p into e to the power of integral p dx y is equal to q into e to the power of integral p dx. This is nothing but the differentiation of y into e to the power of integral p dx, and this is now equal to q into e to the power of integral p dx. So now integrating both the sides, what we get is y e to the power of integral p dx is equal to integration of q e to the power of integral p dx. So there is a dx over here also. So now what we get over here is the solution of the linear differential equation of the form dy by dx plus py is equal to q. Since this is a general solution, we will add a constant of integration at the end of the derived answer that we have got. So now over here, the integrating factor that we have for this question or this type of linear differential equation is e to the power of integral p dx. So the integrating factor we had just talked about is e to the power of integral p dx. So the general solution of the linear differential equation of this form is y e to the power of integral p dx is equal to integration of q e to the power of integral p dx plus c. Similarly, for the differential equation dx by dy plus px is equal to q, we will have the integrating factor to be equal to e to the power of integral p dy, and the general solution of this will be x e to the power of integral p dy is equal to integration of q e to the power of integral p dy plus c. So now that we have the general solution of both the forms of the linear differential equation, we can go ahead and solve a few examples. So let's take up a first example, which is dy by dx minus y is equal to cos x. So first we will have a look at this particular differential equation and check whether it's a linear differential equation or not, and what form of a linear differential equation do we have. So first write down the two forms of the differential equation that we have just studied, which is dy by dx plus py is equal to q. So if we have a look at this linear differential equation and the given linear equation differential, we will see that our p is coming out to be equal to -1 and q is coming out to be equal to cos x. So my integrating factor now is e to the power of integral p dx, which will be equal to e to the power of integral minus dx, which is equal to e to the power of minus x. Therefore, our general solution for this linear differential equation will be y into the integrating factor is equal to integration of q into the integrating factor dx plus c. So now replacing the integrating factor wherever it is given, we get y into e to the power of minus x is equal to integration of what is q? Q is cos x. That is cos x e to the power of minus x dx plus c. So now what we have to do is that we have to just integrate this particular. So now what we have to do is that we just have to integrate this particular function, and we will do it by using the concept of by parts. Since both the functions are different, this is a trigonometric function and this is an exponential function. Therefore, we will use by parts and also the concept of isolate in order to solve this integral. So what we get over here is, it is y e to the power minus x is equal to minus cos x e to the power minus x minus integral of sin x e to the power minus x dx plus c. So instead of writing plus c for each and every step, what we'll do is that we'll write the plus c at the final step. So let me just erase this out in order to reduce the confusion. So what we have further is minus cos x e to the power minus x minus of minus e to the power minus x sin x plus integral of e to the power minus x cos x dx. So what we have done again over here is, we have again applied by parts over here, since both the functions are different, and we'll use the same concept of islet over here. So further solving it, we get this to be equal to minus cos x e to the power minus x plus e to the power minus x sin x minus integration of e to the power minus x cos x dx. So what we have over here is, this is equal to I. And what is my I over here? I is integration of cos x e to the power minus x. So we can write this as I is equal to minus cos x e to the power minus x plus e to the power minus x sin x minus I, and now taking I both on one side, we will get I to be equal to half times sin x minus cos x into e to the power minus x. Now we can replace this I in our general solution equation, and what we'll get is y e to the power minus x is equal to sin x minus cos x divided by 2 into e to the power minus x plus c. Now taking all the x variable on one side, we'll get y is equal to sin x minus cos x by 2 plus c e to the power of x. Now this is the general solution of the given differential equation. Now let us take an example which deals with the other form of differential equation. So let us now take example where we have the differential equation as y dx minus x plus 2y square dy is equal to 0. Now if we have a look at this differential equation, we will not be able to tell whether it's a linear differential equation or not. So in order to really find out whether it's a linear differential equation or not, we need to have a dx by dy or a dy by dx. So let us now proceed by finding out dy by dx first. So we divide throughout by dx. So what we get is y minus x plus 2y square into dy by dx is equal to 0. Hence my dy by dx is now equal to y divided by x plus 2y square. Now this particular differential equation cannot be written in this form, that is dy plus py is equal to q, as we cannot separate P and Q from this particular expression. So now let's try out the other form. In that other form, we will now divide the given differential equation by dy. So what we get over here is y dx by dy minus x plus 2y square is equal to 0. Now divide throughout by y, we get dx by dy minus x by y minus 2y is equal to 0. Now rearranging, we get dx by dy minus 1 by y into x is equal to 2y, which is of the form dx by dy plus px is equal to q. So now we have rewritten our given differential equation in the form of a linear differential equation. So now we can find out our integrating factor. So our integrating factor is now e to the power of integral p dy. So we get e to the power of integral. What is p? P is minus 1 by y. So it is minus 1 by y dy. So integrating it, we get e to the power of minus log y. Now using the properties of logarithm, we can rewrite this as e to the power of log y to the power of minus 1, which can be further written as y to the power of minus 1, which is equal to 1 by y. So now we have our integrating factor. Our general solution now is x e to the power of integral p dy is equal to integration of q e to the power of integral p dy plus a constant of integration. So what we get over here is, after replacing the integrating factor, is x into 1 by y is equal to integration of q. What is q? Q is equal to 2y. So replacing q over here, we get integration of 2y into 1 by y dy plus c. Now further solving it, we get x by y is equal to 2 integral of dy plus c, which can be further written as x by y is equal to 2y plus c. Now taking all the y variables on one side, we get x is equal to 2y square plus cy. So what have we learned while solving the linear differential equation is, we need to know whether the given differential equation is of either of these two forms. If it has been given in these two forms, then it is very easy to identify whether the given differential equation is a linear one or not. If not, then we'll have to rearrange it and check whether the given differential equation is of the form of a linear differential equation or not. Just like in the case of the last example, where we checked by dividing by dx first and then by dy next. So once we have zeroed in on what type of a linear differential equation is, we can find out the integrating factor depending on the type of linear differential equation that has been given over here. So for this particular linear differential equation, we have the integrating factor as e to the power integral p dx. And for this kind of linear differential equation, we have the integrating factor as e to the power of integral p dy. And once we have found out the integrating factor, we will just put that integrating factor in the general solution of either of these linear differential equations which we have in our hand. Now let us have a look at one question which had come in last year's CBSE board paper. So what had been given was that we needed to find out the particular solution to a differential equation dy by dx plus 2y tan x is equal to sin x. And the other thing that was given was, when x is equal to pi by 3, y was coming out to be equal to 0. So let us have a look at how to proceed for this solution. So now if we have a closer look at the given differential equation, it is of the form of dy by dx plus py is equal to q. So we now know that our integrating factor is e to the power of integral p dx. So what is the value of the coefficient p? P is now equal to 2 tan x and q is now equal to sin x. So my integrating factor is now equal to e to the power of integration of 2 tan x dx. So integrating this, we will get sec square x. So once we have our integrating factor, our general solution is now y into the integrating factor is equal to integration of q into the integrating factor dx plus c. So now replacing the value of the integrating factor in this general solution, we get y sec square x is equal to integration of q is equal to sin x. So this is sin x into sec square x dx plus c. Now solving this particular integral, we can do it by rewriting sec square x as 1 by cos square x. So what we'll get is at sec x into tan x dx plus c. Now integration of sec x tan x is nothing but equal to sec x plus c. So our general solution is now y sec square x is equal to sec x plus c. So since we are required to find out a particular solution, we'll be required to find out the value of this constant of integration. And for this, the given data is when x is equal to pi by 3, y is equal to 0. So now replacing this over in this general solution, we get in place of y, we'll put the value of y as 0 into sec squared pi by 3 is equal to sec pi by 3 plus c. Now solving this, we get c is equal to minus sec pi by 3, which is equal to minus 2. Now replacing this value of c in this general solution, we get y sec square x is equal to sec x minus 2. So this is our particular solution of this equation, and this will be our final answer. So now that we have learned how to solve the linear differential equation, please go ahead and take a short quiz of 10 questions on this particular concept and check whether you have actually learned this concept to the level of board's application. So that's it from my side. Let me give an introduction to you. My name is Anshu Singh, and I'm an IIT Kanpur graduate, and I have been teaching for the past 15 years for IIT JEE, JEE Main, as well as for BITSAT for the past 5 years. If you have any other doubts, you can visit our website www.doprep.com and post your queries over there. We will be more than willing to resolve your queries and help you in your preparation for boards and other engineering entrance examinations. Thank you.
So thank you everybody for attending this class. As you will find, there is a link of the quiz in the chat window. You can go ahead and register yourself for that free quiz and take this test in a day or two and see whether you have properly learned the concept of differential equation. If you have any other queries, you can contact us on our website or on our email ID info@doprep.com. Thank you.